The Ethernet is a kind of network where multiple devices are interconnected. Usually, a device called a switch is deployed to ensure the traffic goes well between source and destination. The switch handles traffic based on information learned in layer 2 and layer 1. The device's address in layer 2 is called MAC address or media access control, which comes with the network interface card. Once a card is produced, the MAC address is decided at the same time. Normally, each device's MAC address is unique, so you won't find two network interface cards with the same address. The MAC address is 48 bits long and can be split into two parts: the OUI, or the Organization Unique Identifier, and Vendor Defined Number. Each part is 24 bits long. The OUI can be regarded as the manufacturer's code. So if Zyxel has ownership of the BCCF4F OUI, that means no other vendor may manufacture a network device starting with that same 6 characters. So here's a quiz. A customer finds a set of MAC address B0, B2, DC, 6EAA, 5F. What's the OUI of this address? And which vendor does this device belong to? As we mentioned before, OUI is the first 24-bit of MAC address, which equals to 6 characters. So it should be B0, B2, DC. And we can find lots of OUI mapping tools online. So after we type the MAC address above, then we can figure out this product is from Zyxel. Here's another question. Nowadays, there are usually 2 or more NICs on a laptop, one for Ethernet and the other for wireless. Where can we find the MAC address of these two NICs? We can type the command ipconfig/all on our Windows operating system or laptop. Then we can figure out the two network adapters with their corresponding hardware addresses. Knowing the address in Ethernet, we'll then introduce the traffic types. The first one is called unicast. It means one-to-one communication. From the example, we can see a data communication is happening between a device ending with FB42 and another device ending with C9C4. In the packet captured, we can also see the address information is put inside. Broadcast is a message that is sent to every other devices in the same network. Since there is no particular receiver device, a dedicated address is designed for broadcast traffic where all values are F. We can also see the destination address in the captured packet. Here we have a question. Since unicast can correctly deliver the message to a single device, why do we need broadcast? The answer is explained in the slides, where we can see with broadcast, the data transmission can be done in a single try instead of transmission one by one. This can largely reduce the transmission period and the loading to transmitter. Another reason why we need broadcast is a device may not know the MAC address of all other devices in the same network. Therefore, it's impossible to deliver the message one by one. Next, let's take a look at the third traffic type, multicast, which means a traffic to a specific group of devices. For example, People in the same apartment are watching different TV channels in their room. People watching movie channels belongs to the same group. Those who watch sports channels belong to another group. The traffic from different groups won't conflict with each other. So those devices that are watching HBO won't see NBA on their TV screen. In the slides, the device that ends with 0EB8 can be regarded as a video source and only delivers the message to devices who are watching the channel. Devices in the same group share the same MAC address. For example, an address that ends with 6FEF01. Different addresses are used to identify different groups. Here we have another question. Both broadcast and multicast can send data to multiple devices in a single try. What's the benefit of multicast compared to broadcast? The answer is multicast allow devices to filter specific group of devices to receive the data. So devices not in the same group won't receive the data and therefore their bandwidth won't be occupied. If we use broadcast for the same application, devices that doesn't need to receive this traffic will receive this anyway. The network would end up becoming much more busier and congested. In this quiz, we list down 3 applications in the network. Please categorize them to the most appropriate traffic type. The mail receiving is one-to-one connection, which belongs to the scope of unicast. Watching TV programs belongs to multicast. And the third question is actually a network standard called ARP, which belongs to broadcast. For example, if someone lost his child in a department store, we may hear the service desk use the broadcast to ask the missing child to go to a particular place. For that same reason, if we want to search a specific device from the network, a broadcast is therefore used.